In this example, we're looking at a future savings goal of $10,000 in 5 years. So in the future, I want to have $10,000. And it says I can obtain an 8% compounded monthly. So calculating for the present value, I wouldn't do it using the formula. In my TVM solver, I would put the N is 5 times 12 because monthly for 5 years. I% is 8. Oh, we already have this in there from the previous example. But when we make the payment 0 and solve for a present value instead, we indeed get $6,712.10 as the formula is reporting. But it's not likely that we have $6,712.10 lying around. So I might want to make a series of small equal-sized investments to accumulate to the $10,000 future savings goal I have in 5 years. If you wanted to use a formula, it's displayed for you here on your screen. I don't recommend that method. As you know, I recommend using the TVM solver. So hopefully I can get it all displayed at once. There we go. So my N is 5 times 12. Once again, monthly compoundments for 5 years gives us 60 compoundments or payment periods. I% is 8. I don't have a present value, so I hold that spot with 0. I hold the payment spot with 0. My future savings goal is $10,000. And the PY and CY are both 12 for monthly. I want to solve for payment here because the question asks if I make a small series of equal investments, what would those investments be? So putting these values previously discussed into the calculator and solving for payment, I would get payments of $136.10. Let's see if they're going to let me put it anywhere. 136.10 is the payment that I calculated here. The cool thing about using the TVM solver as opposed to choosing the correct formula and hopefully inputting all the values correctly into that formula in your calculator. I like using the TVM solver instead because I don't have to pick a formula. I just have to figure out what I know, what I don't know, and what I'm trying to solve for. So we are going to look to solve for the present value of an annuity given some known periodic payment or regularly occurring payment. There's the formula. Example 7 says you look at your budget and decide that you can afford $250 per month for a car. To me, that sounds like you bring home $250 a week with your paycheck. I was advised to never finance a car that costs more than a week's worth of pay for the monthly payment. Anyway, what's the maximum loan you can afford if the interest rate is 13% and you want to repay the loan in 4 years? So we have important numbers here of 250, and month gives us our payments and compounding periods. We have our I% of 13 and 4 years, all as our important values. So you can see this plugged into the formula, which I'm not going to do. I'm going to scroll down and hopefully show you the TVM solver with this problem, or at least some of it. So monthly compoundments for 4 years is 4 times 12 or 48. I% was given as 13. I don't know the PV or principal, so I hold that spot with a 0. Problem said I make $250 monthly payments. Future value is unknown, so I hold that with a 0, and the PY/CY are 12 for monthly. I want to solve for present value once again. So Casio owners press the F3. TI owners put your cursor next to PV and press the green alpha button and then the enter key. And when we solve for present value, we should get, I'm going to put it over here just so it'll let me. $9,318.80 when I round that appropriately and use units in my answer. The last example for today, since I know you don't like lengthy videos, we are going to look at an application of the amortization formula. Once again, another formula, lots of stuff to put in, and all the parentheses aren't even there that need to be there. But I have an example. In 2016, the average price of a new house was $291,000 and the interest rate was 6%. Let's say we're purchasing a house that costs that much, $291,000 at 6% for 30 years, and I want to know the monthly payment. So there's all my important values. You can see the author of your textbook has plugged those into the formula, and now I'm going to reveal the rest of the TVM solver at the bottom of the screen. You can see that I put in 12 times 30 or 360 monthly payments at an APR of 6% for a $291,000 loan where I do not know the payment or future values, so I have to hold those spots with 0. And the PY and CY are both 12 for monthly payments. So let's type all that stuff into the calculator. And solving for payment, again, I'm going to put it at the end because you could see how it just made this box much bigger on me when I didn't want to. I get a payment of $1,744.69. If this video helped you at all, please like or subscribe.